Let's talk about unit vectors now. A unit vector, U, is a vector that is 1 unit long in the same direction as some other vector. So let's say the other vector is named V. So a unit vector is 1 unit long in the same direction as some other vector V. And the way we find a unit vector is we take the vector V and we multiply it by 1 divided by the magnitude of V. Okay, so that's what this means here. 1 divided by the magnitude of V times vector V. That will give us the unit vector U. And this would be the vector that is 1 unit long in the same direction. Okay, these are useful in sciences and physics and that kind of thing. So let's find the unit vector in the direction V, in the direction of V, which is given by -3, 2. -3, 2 are the components. So let's first find the magnitude of V. The magnitude of V will be equal to the square root of -3 squared plus 2 squared. That turns out to be the square root of 13. So then what we'll do to find the unit vector U, that will be equal to 1 divided by the magnitude. So 1 divided by the square root of 13 times the vector, -3, 2. So this is just like multiplying by a scalar. And so the resultant vector, U, is given by this. -3 over root 13, comma, 2 over root 13. That's it. So that if it asks you to find a unit vector, just find the magnitude, multiply that vector by 1 over the magnitude. So we just talked about finding a unit vector for any vector, V, which is the vector that's 1 unit long in the same direction. And so it turns out there's 2 very special unit vectors. There's the unit vector that goes in the left-right direction, and there's a unit vector that goes in the up-down direction, okay? So in the left-right direction, the vector that is 1 unit long in the left-right direction, we call I hat. Okay, I put a little hat over it to indicate that it's a vector. You'll notice on your sheet of paper, it's, in the book, it's going to be bold. Okay, so I hat is the unit vector in the left-right direction. J hat is the unit vector, the vector that is 1 unit long in the vertical direction. Okay. So those 2 vectors can be used to write any vector. Okay, so for instance, if I draw in the vector V here, okay, that vector can be written in terms of I hat and J hat. So you can see I could take this unit vector and multiply it by as many times as I needed to get the horizontal component. And then I could take the vertical vector, the vertical unit vector J, and I could take and multiply it by as much as I needed to get the vertical component. So that would be B times J hat and A times I hat. So, and again, this is where, let's suppose the vector V is given in component form. Okay, so there's the component form of vector V. I could also write it in what we call a unit vector notation, which is where I take and go A I hat plus B J hat. So it's like this, A I hat plus B J hat. Okay, so write vector V in standard unit vector notation. So it's given here as -4, 6. So to write that in unit vector notation, we would just write vector V is equal to -4 I plus 6 J. And so that's all. The conversion between component form and unit vector notation is just changing it so it looks a little bit more like an addition or subtraction expression. So that's it.